4.5, we're doing equations of parallel and perpendicular lines. If you think you're already pretty good at graphing, if you're like, yeah, I got graphing, I'm great at that, then go ahead and skip toward the end. If you need more practice on graphing, just a quick review on those equations and stuff, then go ahead and watch this first part. So we'll just start off with the very basics, which is that the slope of a line is equal to the rise over the run. So in this case of your picture here, the slope is 4 over 8 because the rise is 4, the run is 8, which simplifies down to 1/2, right? If this line were going the other way, the slope would, well, if it was going from like this point to this point, the slope would be negative. Note here that we could have a negative rise. It just depends on which way you count. If we count here and go down 4, 1, 2, 3, 4, that's a negative rise, but then we'd have a negative run of 1, 2, 3, 4, 5, 6, 7, 8. So it'd be negative 4 over negative 8, which is equal to 1/2. So just keep that in mind while you're working on these. So we'll start with a little quiz. So go ahead and give me the equation to that line. So I'll pause it. Okay, so hopefully you got an equation to that line, and hopefully that equation is something along the lines of, remember that this is our general form, or the simplest form of an equation is in this form, y equals mx plus b, where m is the slope here, and b is the y-intercept. So this equation form is called the y-intercept form, or slope-intercept form. And so in this case, I put a little dot down here. So this is the y-intercept at -1. So b is equal to -1. The slope of this guy, we just have to find any other point that goes through that line. It looks like this one's pretty good. So we'll go, the rise is 1, 2, 3, 4, 5, -5. M is equal to -5 over, the run is 1, 2. 2, so our equation is y equals -5 over 2x, in this case plus b or -1. -1. Okay, see if you can use your newfound skills to try and do number 2. So pause. In this case, same deal. We can do y equals, what's the slope? Well, in this case, we can go down 1, 2, 3 over 1, 2, 3. Note this is negative and this is positive. Or we could go this way, 1, 2, 3, and then down to -3, 1, 2, 3. Doesn't matter. We got -1x. -1x we can even simplify, right, to just -x. The 1 here is implied. And then the y-intercept here is 3. So plus 3. Okay, I'll do a few more here. See if you can do this one. Pause. Okay, for this one, again, we can do y equals the slope. I'll pick this point here. So the slope is the rise of 1, the run of 5. So 1 over 5x minus 2. We really need to just make sure we can graph. If we can't graph, we need to practice it over and over and over again. I have worksheets and stuff if you need extra worksheets, but we need to make sure we can graph. Once we know we can graph, we can move on to other things. For example, if we were to graph these two equations, this one, for example, isn't in slope-intercept form, so we can rearrange it, right? We can say y equals 2x. I'm distributive property here, plus 2. So we can graph these two equations, y equals 2x plus 2 and y equals 2x minus 3. What do we notice about these lines? Well, if we look over here, we notice that they are parallel. So if these lines are parallel, it's because they have the same slope. So the slope of a line is related to if it's parallel or not. So all parallel lines have the same slope. So keep that in the back of your mind. Now we're going to go to a perpendicular line. So let's talk about this one here. Essentially, they're saying that these two lines are perpendicular. So that means they form a 90-degree angle. And I covered this briefly when we talked about reflections. We had to kind of touch on this because there wasn't any other good way to describe how to find the path that something reflects upon when it has a non-standard line of reflection. But for these guys, we really need to hammer this point home, that there's a relationship between the slopes of perpendicular lines. For example, this guy has a slope. We can find our points here. There's a point, and there's a point. So the slope of this top line here, or this line here on the left, is the rise is -1, the run is 3, -1/3. That's the slope of this guy. Correct? Yep, that black line has a slope of -1/3. The blue line here, however, you look, I covered it up, but there's a point here, a point here. It has a slope of +3. So how are these slopes related? Well, as it turns out, it's called opposite reciprocals. So the opposite simply means that we throw a negative sign in front. So the opposite of 2 is -2. The opposite of negative pi is pi, right? That's the opposite. You just negative or not. The reciprocal part is a little trickier, but I believe you guys can do it. There's two ways to think of reciprocals. One way, the reciprocal of 3 is 1/3. So all you do is throw that under a 1, essentially. So we take 1, we divide by whatever value it is, and that gives us our reciprocal. The cool thing is the reciprocal of 3 is 1/3. What's the reciprocal of 1/3? Well, what is 1 divided by 1/3? We can divide by this thing, or we can multiply by the reciprocal of this. So this is 1 times 3. Or if you punch this into your calculator, you'll just immediately see that this whole weird abomination double fraction thing turns out to be 3. So the reciprocal of 1/3 is equal to 3. If you have more than one value, for example, if you have like 2/3, and you're to take the reciprocal of this, the 2 becomes 1/2, and the 1/3 here becomes 3. So the reciprocal would simply be 3/2. We've swapped it. So whatever is in the numerator becomes in the denominator, whatever's in the denominator becomes the numerator, and they just switch. This still holds up even if we're talking about 3 and 1/3. Look at this. So 3 becomes 1/3, right? But in this case, we could think of 3 as 3 divided by 1. Dividing by 1 doesn't do anything, so we could just think of that. Again, we're just switching the numerator and denominator here to get 1/3. So opposite reciprocals, don't forget, because it's opposite, you have to throw in that negative as well. So blah, 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 blah. Okay. The way they like to define these opposite reciprocals is the product of their slopes is -1. So if you were to multiply 3 and -1/3, right? 3 times -1/3, the 3's would cancel and you would be left with a -1. Okay. We also need to work at manipulating equations a little bit. So just practice. We did the y-intercept form of the equation. We also need to just practice our point-slope form. So you really should know this if you don't have it memorized. Find this equation here in your book, circle it, make a flashcard out of it, have your parents quiz you, whatever it is. You need to know these forms of the equations. This is the point-slope form. It's very useful because all we need then is a single point and a single slope, and we can get the equation. So for example, this problem says we want to find the equation of this line here. And this line is basically defined as this. They say the line parallel to this line, right? They give us an equation. They say, oh, it's parallel to this line. It's not this line, but it's parallel to it. So if it's parallel, what is the slope of the line we're trying to find? Well, it's going to be the same slope as this line. This line has a slope, m is equal to 5, right? Because that's part of this. So the slope is 5. So this line here that we're trying to find will have a slope of 5 as well. And then it's simply says it passes through the point -1, 2. So these are our only three pieces of information, is the slope and the point that it passes through. And the only equation we have right now to make an equation that's valid for a line is the point slope form of the equation. So that is y minus y1 equals m times x minus x1. So we can just plug in our values here. We know what y1 is, we know what x1 is, we know what m is. We can plug those in. And then they just simplify to get a nice simplified y-intercept form for that equation. We'll do an example. So this one, it asks for the line parallel to this line. Note here we can just ignore this part. The important thing is the slope. So if it's parallel, it has this same slope. So m is in this case will equal -3, and it passes through this point 9, -6. So we talked about that. They're going to have the same slope. We know the value for m. That value is going to be -3, so we can plug -3 in there. We know the value for x1. That value is 9. We can plug that in there. We know the value of y, so it's -6, so we can plug it in there. Y, this double negative becomes +6. -3 times x is -3x. -3 times -9 is a +27. So careful of that. Those double negatives are super tricky. And then finally, we can add 6, subtract 6 from both sides. So it's -3x plus 21. Cool. Here's one. So it says, what is the equation of the line through a given point and parallel to the x-axis? So remember, of the two axes, the x-axis is this horizontal one. So if it's horizontal, all horizontal lines have a slope of 0. So the slope is 0, and it's going to be something like that. If m is 0, the equation is often going to be y equals, there's no x because it's 0 times x, so the x just disappears. It's going to be something like y equals 3 or something like that, depending on how high or how low it is. So this asks, what is the equation of the line through a given point and parallel to the x-axis? It's going to be y equals whatever the y value is for that point. Cool. See if we can do 4 and 5 real quick. Okay. Pause. Okay, 4, we're going parallel to this line. This one's tricky. The slope here isn't negative. There's a little hidden 1. So the slope is -1 because we're going parallel. And the point is 5, 2.5. You can simply write out the point slope form. So y minus y1 equals m times x minus x1. Then we can plug in our values. Y, we're subtracting this value, 2.5 minus 2.5 equals -1 times x minus 5. We can distribute this, equals -x plus 5, and then finally y equals -x plus 7.5. Okay, similarly, this one here, same sort of deal. I'll just skip that one. All right, now if it's perpendicular, since before it was parallel and we just took the same slope, this time we're going to take the opposite reciprocal. So for example, this one here, it asks us to write an equation for this line. It says the line perpendicular to y equals -2/5x plus something. So note here that the slope of this one is -2/5. So the slope of the line that's perpendicular to it, right, it's going to be a very different slope. It's going to be the opposite reciprocal. That slope is going to be the reciprocal being 5/2. Oops, sorry. being 5 over 2, and then it's going to be the, whoop, I put the negative in. It's all part, okay. It's going to be 5 over 2, a positive 5 over 2, right? Because it's the opposite value. So the slope is 5 over 2, and it passes through this point, and then from here on, it's the same problem. All I have to do is, again, write out point slope form. I plug in my values. In this case, it's negative 8. The slope is 5 over 2. The x value is negative 6. And then I simplify and I get my equation. Okay, we'll do another one. See if we can do number 7. I'll walk through this one. So go ahead and pause. Okay, this one asks, again, for a perpendicular line to this equation. Again, that part is irrelevant, the y-intercept, because we're just concerned about slope here. The slope is 3 over 2. So what is m? It's the opposite reciprocal of 3 over 2, which is negative 2 over 3. And that passes through this point. So I'm going to write out my point slope form. Y minus y1 equals m times x minus x1. And then I can fill those in. Y minus this thing, which becomes a positive 1, equals and then we can distribute. Negative 2/3 times a negative 3 is a positive 2. And then we subtract 1. Minus 1 plus 1. So that gives me a final answer of y equals negative 2/3 x plus 1. Notice here that the slope is negative 2/3, right? It doesn't change as I go through this equation. So that's just one double check that, oh, did I do this right? The slope should remain unchanged. Okay, I'll go ahead and do this one too. This one asks for a line perpendicular to y equals negative 4x. So again, this is my slope. This is my intercepts here, or the point that I go through. So what is the opposite reciprocal of negative 4? Remember, it's negative. You can think of that as negative 4 over 1. So we can switch it, and it becomes positive 1 over 4. So I'm just going to put 1 over 4. And then I'm going to skip writing this thing out. I'm just going to plug the values in. So in this case, I have y plus 0 equals my slope, 1/4, times x minus 0, which is x, so 1/4 x. Y equals 1/4 x. Okay, that's it. That's all I got. Okay, have a good one.